your life.
Thank you very much.
When?
To send ordinary picture, it was behaving like if
that's not nice.
no, not at all. He was the last person to send the picture.
His own business. So he's gonna make everywhere.
He was the last person to send picture. And you are communicating on the platform 247. What did he keep sending picture? I beg you, I don't know what it was.
Probably the most disappointing of all cases. The most disappointing of all cases.
Have you called the guy?
Good morning, ladies and gentlemen. Sorry was starting behind schedule. The union of the class 2000 of the final civil engineering University of Ibadan have started. So we want to welcome everyone. They are going to be led department, Professor GM Ayinola. So we can sit down. Now, sorry. Before the national anthem, I want to say the opening prayer by Engineer Abiola Kanu.
Our Father, we want to thank you for today. We want to appreciate you for helping our plans to pan out as we have planned for this event over the past few months. We thank you for joining us for all that have come and those that are still on the way. We commit this meeting to your hands. We ask that the utmost desire in our heart to be a blessing to our department and to new generation of students. Lord, let it come to pass in Jesus' name. At the end of the meeting, we ask that you take all the glory to yourself. In Jesus' name.
Thank you very much. We'll go into the national anthem and the school anthem. Let us stand up and take the national anthem. greatest you are. Greatest of the greatest of the greatest you are. Thank you very much. You can sit. Now on the agenda, we are going to have an introduction of the class. And I want you to look at the PowerPoint presentation that is going to introduce members of the class. So, I'm sure some of my classmates, they will deny that that was not their pictures. When they were here. Press like I did not so that I got this together. Thank you. So before the introduction of the class using the PowerPoint, I want to first of all introduce and recognize our host this morning. It was when we were here as undergraduates. He was, I think, 2 sets ahead of us, and his nickname then was what? He has a nickname when we were here. They call him HOD. That was his nickname. Well, he's HOD. He's HOD. We know they were referring to him. Now today, that prophecy of over 30 years has come to pass. So I have the privilege of introducing to us this morning the head of department, Civil Engineering, University of Ibadan, the one and only HOD, Professor Also, we know other lecturers are seated. I will introduce one woman who has been very, very nice. I will introduce her in absentia. One of our teachers, when we were here, he was a very young man. You know, very shy. We talk of me, Baba Fantola. Are you a thinker? Talk of me, Baba Fantola. Are you a thinker? If you are not a thinker, you cannot. If you are not a thinker, you cannot be an engineer. You understand? Baba Fantola, blessed memory. Then my own of blessed memory, the late Dr. G. Alade, who taught me structures. I want to appreciate him also. Baba is late. We have with us Dr. Franklin. He was the head of the department when we were graduating from this school. Now also Professor Polati, then Engineer Polati took us. Akideji. Then we have then now Professor Lutoge, who took us steel design and reinforced concrete design. So who else? Engineer Olabode, Akidele, who took us soil mechanics. Baba Bedere, I want to commit the Professor Agbede, you know, he took us engineering geology, the water management and stuff like that. Then one and only architect in our department. Then we have some who bears his name here, quote and unquote, Polari. I think God was going Polari Adebamowo. So, architect Adebamowo, you know, she was one of our teachers then. I think those are, and when other names want to mention them. So, we want to appreciate them for the impact they made in our lives. We are where we are today because of its discipline that were invited into our life. So for the present lecturers who are here, most of them are new. That's why, sorry, I don't remember their names. I have about 4 of them seated there. Please, the camera. I don't want to embarrass them. These are the new set of lecturers in the department presently. We really want to appreciate you for coming. God bless you. You can have your seats. Then Professor Damzi is unavailable, absent also. He's one of the lecturers in the department presently. Then of course one of us, my twin brother, one and only Alpha Excel. Alpha Excel. Professor Wasiu Ọlájẹ́ Àjàké. So our class is a class of thinkers. We are very blessed. No, we have people in the industry. Later we will interact with us. Others will still for me. We have people in the industry who are doing fine. One of us came from the United Kingdom. He has a big friend who was there. He's into technical engineering. He has made us speaker today. Let me introduce him, Abid. Engineer Abid. You're welcome. Then we have one auntie. She just got married then. She was our auntie. She knew everybody. Because when you have any problem, say, Mrs. Safumi. I want you to help us with a big ovation. Welcome, Mrs. Safumi. Thank you very much. Technologies who are here. Now, you are going to see some slides, some pictures that some of my colleagues have denied that it was not them. It was someone that helped me to retrieve this. Shayo, Mr. Shayo, please, I want you to stand up. So, everything you see today, don't come to me. You should go and arrest him. Thank you very much, Mr. Shayo. So, the media team, please, you can help us do the introduction. Thank you.
Wow.
During that time, some people did not have pot belly. But now they are eating all Nigerian money. So, not to waste time, I want to introduce the chairman of the planning committee to come and do the welcome address. Engineer Abiodun Olopade, aka Masters.
That was in my picture you saw. The head of department, the distinguished lecturers and students of the Department of Civil Engineering, University of Ibadan, my friends and colleagues of the Civil Engineering class of 2000, invited guests, ladies and gentlemen. Good morning, everyone. I'm deeply honored to stand before you today as the chairman of the class of 2000 Reunion and Feedback Committee to express a sincere appreciation to the department that gave us so much and laid the foundation for our various careers and accomplishments in life. My colleagues and I began our journey here at UI in Ibadan in 1994. And by the grace of God, with the unwavering support of both the academic and non-academic staff of the department, we graduated successfully in the year 2000. We spent about 6 years, 6.5 years in the department. In our class, like you saw on the slides, we were 37. Today, 36 of us are alive and well and doing very well. One of us, Mr. Bola Olatubosun, is of blessed memory. Ms. Jetiso continue to rest in peace, and may God continue to comfort and sustain the family left behind. Today's visit is centered around 3 key objectives. First, we want to say a very big thank you, a heartfelt thank you to all the staff of the department for all you did for us and for other countless students that have passed through the department over the years. Thank you very much. Secondly, and very importantly, we want to interact with the students. We want to share our experiences, our lessons, our students for the opportunities and the challenges that lie ahead after graduation. We hope that these engagements will strengthen the bond between the current students and the alumni community. And finally, we're going to visit the department to donate multimedia equipment for the classroom. This is a token of our contribution towards enhancing the teaching and learning environment for the department. It is our sincere hope that these gestures will inspire the students, support the staff, and contribute positively to the continued growth and excellence of the Department of Civil Engineering, University of Ibadan. And before I conclude, I would like to especially appreciate all members of the class of 2000 for all their commitments, the generosity, the donations that's making this a reality. We made personal sacrifices and financial contributions. May God continue to bless and prosper every one of us and inspire us to continue to support all the causes like this. Thank you all very much for being here today, and I hope you all enjoy the rest of the program. Thank you.
Thank you very much for that thought-provoking welcome address. Now, a good big message by the one and only HOD of the department, Professor G.M. Ayinola.
Thank you very much, Akinwale. I changed your name from Olawale to Akinwale the very day you stepped into my office. And I took permission from your wife before I do that. Now, I want to start my speech by saying that the class we have today is called the class of 2000, right? But I want us to know that in year 2000, a lot of things happened. Even that we are having them today is by God's grace. I remember when they were doing their projects, there was this rumor. Who can remind us? I'm sure we're in the midst of great things of 2000. What happened in the year 2000? Who can tell us there? Let's start from the chairman. What happened? Why were you afraid of your project? Who can tell us? Nobody. Yes.
That will crash.
God bless you. So this is a class of Y2K, not 22. That you will even think of coming back to say thank you. How many people just face a little and they cannot even come back to the system and say thank you? So I am very, very grateful to you. On behalf of the department, you have really done very well. Even I can say that alumni will come to assist us. If you remember, when you graduated when the department was in 2 flats, only 1 floor. But now we are giving 4 floors. So we see that what we have will not be able to occupy the 4 floor, and we need more material and have come our way. Let's have a lot of applause for them too. Let's come with them. We are looking for how to make our classroom to be the test of time, and they have come to our way. When they discover something that so said is planning to do this and that, would that not be true? Until when I saw it, I was Thomas. But now I'm not that Thomas. Because you have put me wrong. So I want to use this period to sincerely thank you for what you have done. And I pray that the students who are here, one day they will also reciprocate. Let me say this thing. Alumni, they have been coming to the day. Engineer Babala came several times alone to assist the department. Even others, Engineer Mapale 2010 also came. He visited the department. Just like they play, he also made a general donation. How many as a group? We will come together, gather together like this. Now we have one of the ladies who graduated from here. We are welcome. Yes. So you can see that this is a unique time that we need the alumni. Please, students, they are here for your own good. You know, I said that when they were here, things were very hard. There was not like laptop. How many computers did we have in the department then? Maybe 2. And they maximum curriculum. So, but now things are very, very easy. If you were there, you have all it takes to excel. Honestly speaking. So, I just want to sincerely apologize, sincerely appeal to the students. Please listen to them. They are the great thinkers. Because I remember, if you go anywhere, you say that you graduated from civil engineering. Are you a thinker? You say, I'm a thinker. Now, when you respond, I'm a thinker, then that is the logo. Whatever that individual is looking for, the alumni will answer you. But if you say, are you a thinker? Say, sir, what? Pardon? Say, sorry. You are not from civil engineering. That's our logo. So please, I really thank you. And as sincerely, we are grateful to you for what you have done. And my hope is that by the time you go around, just like Bola Ige said to people in Ila, he said that the way I left you is the way I met you. But you'll find out that we have gone far. And also, this is also to appeal to you that what you are going to run, we appreciate it. But help us also to reach to other alumni. We want them to come and register their presence. It's our property. It's our department. It's not my own. It's our department. When I was in my undergrad, they called me HOD. Little did I know that I will still come back and become HOD today. But today I am. And we're here together. And I give God the glory. So once again, let's welcome all of them. Let's give a round of applause. Thank you very much.
Thank you very much, my HOD, Professor G. Emmanuel. and my host presently. One of us just walking, she's the Yaito of the department. You know, Yorùbá says, Tọmọdé bá máa jẹ́ àṣàmú, kékeré ló ti máa ń ṣẹnu ṣámúṣámú. She has been doing it since when we were undergraduates in this school. I remember then she always traveled to Cotonou. She has been a businesswoman since our undergraduate days, and today she's still a businesswoman. I want to welcome specially, I won't call you by your husband name. I will call you the name we call ourselves there. She's Esther Omuyiwa Jo. You're welcome. Like the HOD said, this is a class of thinkers. In the past 26 years or so, God has really helped us. He has preserved our life. Apart from our colleague, Bolahon, that we lost. Unannounced. And Omomomi. Omomomi, unannounced. In those days, I think his mom used to work at Works and Services. So the mommy normally helped him to bring food to come and visit him. To us then it was strange. In our old days, you are on your own. No? So his mommy coming to him looks strange to us. So we call him Mommy. We pray his soul will continue to rest in peace. So in this class, by the grace of God, we have people in the industry, in the banking industry. Oga Banker, unfortunately, he could not come. He's one of the organizers. You know, his bank have to send him out. So that's why he could not make it here. We have those who are in the oil and gas who are doing fine. As you interact with us, you get to know. Then in that class has 4 professors. 4. I don't know whether there are any other class that have that privilege. 4 professors, my humble self, professor of structural engineering, my twin brother, Professor Ajagbe, also structures and environmental. Then my dean in Abeokuta, summer is in Abuja presently. You know, this dean thing, you have to travel. So he won't be back until tomorrow from Abuja. Professor Adedayo Badejo is into water and environmental. Is my dean in College of Engineering in Funab. And one of us, he was very quiet when we were in school. I think there was a nickname we normally call him, Undertaker. Undertaker. He was quiet, he won't talk. You know, even if you abuse him, he won't say anything. He's a professor today in the United Kingdom, Professor Sheikh Kolade. If you could not make it, but he has sent his message. So, and we have others who are doing fine in the industry. When you meet us, you can go. So, it's a great class, it's a class of thinkers. It was very tough when we were here, but somehow God see us through. And that's why we are here, to encourage the students here. You know, all those steel design, structural design, you know, when we teach you, you say, what's this man teaching us and everything. By the time you start practicing, you now appreciate that, yes, something is being passed across to you. Not to waste our time, we go into the next item, which is keynote address. From our main speaker today, we decided to make it everything ourselves. You know, you would have said, okay, let's invite a keynote speaker. We said, look, we don't need someone from outside. God has blessed this set. We have, virtually everybody in different field of engineering, in the industry. So we have to call someone from us to address us this morning. I want to call here, is based in the United Kingdom, is into geotechnical engineering. In fact, whenever I see his picture on LinkedIn, Facebook, I was like, wow. He has handled so many. So I want to introduce this morning one of us. Fortunately, he was the president of Access. We were Access, not Nicesa, Abi. So he was the president of Access in our sets, Dr. Abidemi Adekunte. Let's stand up and welcome him. Students, I welcome him.
Hello everyone. It's just so delightful being in front of you today. I've not been here since November 2000, approximately 26 years ago, graduation day. But wonderful memories of the civil engineering department. We had some wonderful lecturers, and they gave us really solid foundations for us to go out there, to get outside the world, and excel in the outside world. The swimming was in our class, doing exceptionally well out there. So we are eternally grateful to the civil engineering department of Ibadan for making us what we are today. Before I go ahead, I think it's very important for me to express my sincere gratitude to the planning committee of the Civil Professional Union, headed up by engineer Ibadan, they can exceptionally well. We all are very busy, they're very busy themselves, but despite that, they've had to sacrifice loads of time and resources and put a training program together and put these program today. So this was a credit. So if you don't mind, please, I would like everyone to stand up and do the standing ovation, please. If you don't mind, please. Yeah, give us a break. If you want to. Your personal choice of a career path. But before I start advising yourself where exactly what your career path should be, it's very important, fundamentally important that I talk about personal career paths. So I start talking about that now. Yeah, so I graduated from the civil engineering department in May 2000. After graduation, I joined PW, an Irish construction company, one of the biggest around there. I'm not sure if it's still one of the biggest now. Okay. Yeah, PW and then working into Hack scheme, which was the organization of Ibadan to Learning Road. Then that scheme got divided into 3 sections. So Ibadan to Oyo went to PW, Oyo to Bumosho went to Juliusberger, and then Bumosho to Learning went to RCC. So it's 24 and Ibadan to Oyo as a tech engineer, and had some wonderful experience and doing systems for higher extreme stuff, great experience. Do my PhD in foundations. So because of that, I thought it was really important at that stage for me to have some really good experience, some experience in foundations and Lagos. Maybe the best in the land. Maybe the best in the land there is the best in the land now. The biggest goes go to them. So I want to experience in planning and deep excavation support systems and ground improvements and ground investigations, which was so invaluable to me from my PhD in Dublin. So when I left Nigeria in 2002 to go to Dublin my PhD, the PhD was fully funded, and so funding for the research itself, personal upkeep, the school fees, everything, because it's actually funded by 2 different agencies, Sustainable Energy Ireland, and then the Industry Supply of Ireland. So it had some nice experience in Dublin then, research. But apart from that, about my PhD, one of the sponsors, ESP, They gave me a chance to actually work with them on the part-time basis as a design digital engineer. So I actually went my PhD research with actual digital practice, working on energy projects in Ireland, Saudi Arabia, Ghana, and Vietnam. So I had some wonderful European experience working on a PhD. So it made it so easy for me having a PhD just slopped in straight to the system. So I was supposed to be ESP, but I got a better offer from a different company. So I took a different company, apparently Partners Ireland. But over the years, after that, I worked with different functional specialists, consulting firms, money specialists, contracting firms in Ireland and UK. But eventually, in 2012, I set up the functional specialists. We got offices in the UK and Ireland, work on major projects in the UK and Ireland. We specialize in design for underground structures mainly. So the foundations, ground improvement, deep expensive support systems, multi-level basements, underground car parks, underground swimming pools. And we were well known in the UK and Ireland for that because there are not too many companies that do what we do. Next slide. Yeah, so let's talk about your main priorities now as undergraduates. Because we never had a chance to have anyone stand in front of us and advise on where exactly we have to do then. We went into the wall blindly, we knew nothing. So when we that on God, we do things right. So go back to that. Yeah, so the main priorities, it's very important that you strive to come up from University of Ibadan at least second class qualification. Yeah, things are there. As an example, if you come with to one in first class, and you can Ireland, you've got a chance of actually going straight on your PhD, that will be masters. And that was exactly what happened to me. So after the first year, I actually experience in a journey, just went straight on the PhD, but I came up with something better than it's two. So it was so helpful. So that's the reason why it's so important to try, give your very best, make sure you come that way, that is a 2-1. Hopefully, by God's grace, we will achieve that. Also, most PhD positions, especially in Ireland, they are funded. Partially after which reason they are paid. But also, because of that, you will do pretty well. Because it costs quite a lot. It's going to cost you £40,000 a year to actually go to a PhD or a master's program by research. And if you need a PhD 3 years, £420,000. So anyway, so it's so important make sure that you get this tool and make everything for yourself. And also, take another side, industrial training. Your industrial training, you don't take your industrial training so seriously. In my own case, I have my they will see this report, some wonderful experience on bridges, and I work on the river bridge, a bit with them, first concrete bridge, and also work on the river bridge, in Ibadan, the part between the state and Lagos State. Good experience. On that Ibadan project, that was actually the first time I actually experienced planning. That was the first time I saw planning people take. And that's exactly what I do today. Every single day, we send them out. So I explained that on the undergraduate days and what I'm doing my IT. And the sickness of books. So that's important. It's actually exposes you to real life practical experience in the undergraduate days. And that actually helps to actually visualize the thread of works, the calculations, undergraduate days. You know what exactly you're designing. You know exactly what design actually putting things inside. So taking your industrial training very, very seriously. And also, after graduation, it's really important that you try your very best to contribute to the industry. I'll go back to PhD again. And not necessarily PhD only, but even research masters of research. what PhD does just to me is this. It's actually changed the mentality of me from being a listener to being a talker, from being a watcher to being all things, and from being a passive professional to an active professional. And that actually allows you to stand out in the industry, especially the industry. In that area, you may not stand out with those PhDs, those business specialists that can about what the industry from. Progress very quickly. You've got that mentality of actually impacting knowledge in the industry, trying to change things, trying to do things differently. And then that's the case with me. I've always, once I got my PhD in some of the industry, I've always contributed in talking at conferences, writing journal papers, workshops, and organizing seminars, and that helped a great deal. And also, I built a huge network. I got to set up my own company, and then if I set up a company, that kind of business was already there because I was already well known. So the point is this: so once you leave the university and start practicing, just try our very best to always try to contribute to the industry in multiple ways, writing papers, talking conferences, having workshops, and if that gets noticed, and if you get noticed, people try to take the DM first to one thing they do, and then before you know, you get extremely well in the industry. So it's important. Yeah, let's move on. Next slide, please. Yeah, so let's talk about the factors that are influencing student practice all over the world, and then consequently, that will influence your career path. Once you get university and start practicing the industry. Greenhouse gas emissions, they have a major impact on the environment all over the world. They have an effect on rainfall patterns, more flooding happening, high temperature over the world, so many other ways. And then governments are not happy about it, so they are changing things. As an example, coal-fired power plants, gas-fired power plants, they become obsolete now, especially in advanced world. I'm not sure if that's the case in Nigeria. I think it's not also coal-fired gas-fired plants become obsolete in advanced world, and then moving away, they get into renewable energy, wind farms, solar parks, sticking with them hydro power plants, nuclear power plants. So things are changing, and also planning restrictions are limiting the height of building, especially in urban centers, because they've got some negative effects, and they actually influence the historical skylines, major urban centers, especially London, as an example. So we don't really forget the high, but they start to affect the historical skyline, and not the historical skyline, bring loads of tourists from all over the world. They want to see London, they see Tower of London, they want buildings and overshadowing those, and also private citizens don't want them built overlooking their buildings, and also for any political reasons, being able to look at the sky. So because of that, we talked to developers about doing the maximizing of floors and buildings. So instead of going up and up, that's going down and down and down. So you have more beds on the ground, you have carpets on the ground, swimming pools on the ground, and not just on new projects, but even on the existing buildings, really. I'm taking Trenchard Hall as an example. We can actually design one or two level basement, or any kind of things now, right to the right standing. So that's what we call segmenting on the being all around, and then digging on the building standing. So that holds a lot of demand for that now, because buildings are not allowed to come and play again. They're actually getting deeper and deeper on the ground now. Next slide, please. Yeah, so the third thing that's actually influencing civilian practice significantly artificial intelligence, AI. But the interesting thing is this, at this stage, AI is still having very marginal influence of engineering practice, civil practice, and structural engineering practice. So because of that, we've huge potentials to actually get into AI, or use AI to impact civil structural engineering practice. One thing you need to understand is this, to get into AI. Before I go into that, we have made loads and loads of requisitions for new data centers now. We actually work on one now, and it's going to be the biggest data center in Europe, and somewhere in East London, and it's got about 3. That will be a domain knowledge. There are loads of AI tools around now, but because the domain knowledge of the developers is limited, so those AI tools actually end up being useless or being inconsistent. But if you've got the sound domain knowledge of civil structural engineers, you're in a better place to actually be part of those teams and putting AI tools together for similar structural engineering applications. So once that sound knowledge is there, and that's what you trying to achieve now. Once that sound knowledge is there, the next thing for you to do is to make sure that you actually expand the knowledge of computing and programming, which is not difficult to do. Some people are getting into IT now, we know computing environment and exceptionally well. So expanding knowledge of programming and computing, it actually too difficult for you to do. So once you've got that knowledge and that domain knowledge of structural engineering, the next thing to do is for you to go a master's in computational engineering or structural informatics. And then once you've got that, you will have that very sound knowledge to actually get involved in AI tool development. So in that case, eventually you'll have to find an engineering consulting firm and a digital team within that engineering consulting firm. Now, many of them, many consulting firms now, they have a digital team within them. So get an engineering consulting firm and be part of that team. Alternatively, you may join a university with a research group that focus on AI development. But that scope is there, and those kinds of opportunities are there. So now we'll look to explore now. Next slide, please. Yeah, talking about so many governments deviating away from the traditional coal-fired power plants and gas-fired plants and embracing renewable energy, especially wind turbines and wind farms and solar parks, but and also nuclear power plants and hydroelectric plants. But the engineering knowledge supporting nuclear power plants is established over the years. The engineering knowledge supporting dams and electric power taken over the years. But the engineering knowledge and also solar parks, the engineering knowledge of solar parks is so nice and straightforward. Nothing difficult. You see it all there. But they are very sensitive structures. Dynamically sensitive, and they are subject to significant overturning moments and horizontal loading that are significant fractions of the structural dead rate of the structure, and which you don't know when we get in the conventional structures. Conventional structures is the structural dead rate. Horizontal loading, wind load is actually a small fraction of the structural dead rate of the structure, so that's easy to deal with. But the wind turbines there, the horizontal loading, the horizontal loading is huge. They function exceptionally loaded. So because of that, you need specialist knowledge and actually improve in that industry. So because of that, you've got a severe skill shortage in engineering for wind turbines, but structurally, geotechnically, even mechanically and electrical. I know that's irrelevant. But because of that huge scope, you get room to get involved. And that's one thing that will let you get to looking into as undergraduates huge role there, a huge role to fill in there. And there's so many consultants, engineers, there's so many industries involved with them, we talk and keep looking for loads of engineers. So that's one area we can look into. Next slide, please. Yes, still talking about wind farms and renewable energy. Taking my own case as a simple example, I have my research, my PhD research in foundations for wind turbines. That top photo shows me standing on one of the turbine foundations that are actually instrumented and then monitored for up to 2 years. Actually instrumented and monitored 3 different wind turbine foundations in Ireland. So one was down south on the south coast, a place called Council in County Wexford, down to the Ireland, monitored one in Central Ireland, and a place called Cavan, and Stamford Winker. And there was one on the west coast of Ireland, Galway. The interesting was that they were actually in different duration settings. So the following generally similar ways, but the rate distinctive and performances of behaviors are several different duration settings. This is so interesting. I have pressure cells, piezometers, learning cells. Brought together and then connected to a thermal cabinet. You can see me standing, that bottom portion should be standing next to my thermal cabinet on the strong growing fan. So you can see the reservoir, learning cells in there, having data logger, multiplexers, and having GSM transceiver. So I could access the data logger, download the data from the data logger, what is it? That's already done without actually having to go out on site. So there are not so many funded, pre-funded, partially funded research positions in the wind turbine engineering, the foundation aspect, structural aspect, in the UK, Ireland, and North America, and in the advanced world, which is actually strong. And then I also lucky, I've got a pre-funded, I said that I'm pre-funded PhD research, and PhD research position, and foundation wind turbines. My eventually more my research was about was that eventually I came up with a new macro model for the design of shallow foundation wind turbines, and also applicable to the eccentrically loaded foundations, because the wind turbine foundations are eccentrically loaded, and that when they're eccentrically loaded. It's a good foundation, and then it's not been doing through the center. I mean, the results of the loads on the center, the away from the center, one can completely deal with. And I think traditionally, the main house effectively approached all the way back in Ibadan then, but then it's quite conservative. So my primary models have been produced now, and I produce one of those, which is quite consistent. But the previous one from my own macro model, when it comes to aspect ratio, embedment, so my own macro model actually accounted for the embedment and aspect ratio, which is an advancement of all models. But there's still loads of regions going on subjects and wind turbines, and that's something we should be looking into. And I mean, probably your shoes that are looking into those. But one thing about this is it's so complicated with wind turbines. There's huge shortage in that area. Engineers every now and then, from graduate level, experienced engineers every now and then. So that's an area you want to need to get into, and then you can get in there and know what you're doing, you will excel really well. Next slide, please. Yeah, physical planning restriction in urban centers. I spoke briefly about that. Most urban centers now, developers are not being allowed to actually build really high structures. For several reasons, overshadowing neighboring buildings, affecting historical skylines, which is not very demand now for basements as part of neighborhoods and basements underneath existing structures. So, and that's the case with many urban centers. Even away from urban centers, there's one project we're working on now in Coventry. Coventry is in West Midlands of the UK. And it's a hotel, and then the developer actually wanted 6 floors in the hotel. But the surrounding buildings are actually 2-4 buildings, 2-3 buildings, 2-4 buildings. They're not allowed to actually go above 2 floors above ground. I think it's 6 floors, so we actually have a 4-level basement on the ground. So we've got 4 floors above ground, we've got 2 floors above ground. So standing on the street in that building, you see 2 floors. They actually got 4 floors underneath. I mean, there's so many cases like that. As an example, look at that quarter there. That's another job in Dublin. It's a 2-story basement, 2-level basement. Eventually, it's a block of apartments, but eventually you have 4 floors above ground and 2 floors below ground. And next slide, please. Yeah, this is a very interesting one. This is a big basement, a 3-level basement next to the Eastern Station in Dublin. They developed part with their program to have 7 floors. Block of resident apartment, 7 floors above ground, but they wanted 10 floors, so he had to do 3 floors below ground. And that shows that 3-level basement started from the bottom and then coming up. But before the commencement of the excavation of the basement, we have installed what we call a secant retaining wall around the old perimeter of the basement. And then was made capital beam on the second wall, and then installing tie-back anchors to restrain the retaining wall once the excavation starts and going down. But there are lots of restrictions on this job. The Irish authorities, Irish law, they specify that the retaining wall must not move that further by more than 5 mil, and also because those translation tracks, railway tracks behind the wall, those railway tracks are not allowed to 0.5 mil, so there's restrictions. So we have to make sure we know what we're doing, and we were digging down by 11 meters, so 3 levels, of basement. So it was quite complicated, but eventually we got it done. And the maximum schedule we had was 3 mil. So there's an effect that was specified, and there were no movement on the railway tracks. And the work that was going on, everything that was going on, and the railway tracks were allowed and never stopped operating. So we could know exactly what we wanted. So that was very interesting, quite rewarding technically. But one thing I need to tell you about is the excavation support system adopted on that project. You can see those tiles, you can see the tiles are actually holding the ground together. It's a secant tile wall, so you can place over male, female tiles on top of each other, or you can call them hard and firm tiles on top of each other. And the reason that they interlock each other is to ensure that there's no water coming, because the water level was very high behind that wall. The water level was very low on that side. So to make sure that it seals up the groundwater, when you don't touch coming through, you have to interlock each other for the perfect groundwater cut-off system. So that's a secant tile wall, interlocking tiles. Next slide, please. Yeah, these quite different. That first slide, that slide showed interlocking secant tiles and interlocking each other for groundwater. But you can see a different wall now. This is actually continuous parallel retaining wall. You can see gaps in between the tiles. And the reason why you've got confident continuous tiling is because the water level was very low, so we would never have to dig with groundwater and dig it down, no water coming through. So it took the unnecessary having a secant parallel wall in that case. And also, you can see raking props. Those steel structural steel raking props restraining them because we had a 3-story building directly behind that retaining wall. So we have to make sure that the tiles don't move at all, because they move just minorly. Because if the tiles move towards the excavation, you start having cracks in that adjacent building, which you don't want. You there'll be issues, so we have to temporarily restrain them with those structural restraint props, structural restraint props, connect to the copy on the power, and also we've got them press box underneath. You can't see press box, you know, until underneath that's the bottom. And then we have to limit the movement of those valves to a maximum of 10 mil. We actually recorded those 3 mil. I've got to tell you about how exactly we monitor the movement of the valves. We have always our inclinometers installed within some of the valves. So the valves are reflecting the inclinometer moves, and the inclinometer is connected to the data logger. And that is a number that tells you the actual movement of those valves in the mill. Then this is also important in this case, because we don't want too much of movement, we also have cartoon neighboring building behind that power wall. This is the single to double basement. Next slide, please. Yeah, this is another one. Continuous power also in this case, but the difference is this: it's actually a freestanding cantilever back in the wall, so no temporary structural strength props, no tie-back anchors, it's just freestanding. So we have to design a power wall just for construction and deckment below excavation level, and to allow that retaining wall as a freestanding cantilever. And in this case, because there's no building behind the power retaining wall, and we were allowed to actually have movement of 25 feet, and I think we got 18 mil or so. So yeah, rewarding on external achievement. Next slide, please. Yeah, I think two of the retaining walls that's only in the basement, they have come up with a retaining wall. So they showed an anchor area putting one of the tie-back anchors. Essentially, what they put in the carpet beam on the retaining wall, they have holes in the carpet at intervals. So allow the anchor to drill through the carpet and to the back of the wall. Pumped in ground behind the wall with an angle, and then introduce a central tendon. Tendon is a solid bar, and then you get a grouted up, and then you take off the temporary casing. And after that, once the gut kills, you stop at the top. I'll show you what that looks like on the bond capacity between that central bar and trying to grout, and then the actual capacity of the tendon itself, maintain the overall stability and stability of the retaining wall. Next slide, please. I would want you to mix up count the question in terms of how exactly they function and how exactly they get installed. Soil nails are actually used to stabilize slopes, and they reinforce slopes. Installed for a cotton, establish a cotton as part of the highway expansion scheme in the UK. If you look at the right-hand side of that report, you can actually see a number of those soil nails already installed. Soil nails actually allow slopes to stand as steeply as possible, with not angles of 80 degrees to be horizontal, which you can't really achieve without soil nails. So they are very, very efficient at stabilizing slopes, reinforcing slopes, and making sure that slopes stand as steeply as possible, especially if you've got limited space. Especially that, as an example, is highway expansion scheme there. Next slide. I was talking about from that street that this is the starter shaft. You've got to construct the starter shaft first. You've got to construct the starter shaft first. A reception shaft at the other end, and the tile here is going to start the shaft and the reception shaft. The tunnel boring machine gets lowered down the starter shaft and starts boring horizontally along the tunnel alignment, and then bursts out through the reception shaft and gets lifted out from the reception staff. So these are the such tunnel boilers that we're involved with in the UK. You can see that workman in our area at the bottom, so tiny. Loads of things that are going on now, but there's so much strain on the service assets. Yeah, I've spoken quite a bit about instructions on the severe skill shortage in that area, probably because it's not very straightforward. It's not just about basic fundamental solve mechanics, it actually involves a lot more. And you know, the solve mechanics, very some understandable, just in engineering and structural engineering, it's actually functioning technically. Whatever the two structures. That's probably why the lots of skill shortage in that area. But we're prepared. We've got some knowledge, just kind of structural wise. Once you get to that, you will do really, really well. You will always be in demand. From employees, from several agencies, locally, internationally. So I think it's an area that you're going to look into really, because as a consultant, we are so busy, struggling with workloads really, because the demand is that there are not too many companies, too many consultant firms that specialize in this, because it's such a niche area of engineering. So that huge room is there, that huge scope is there for you to get in there and just excel in there. And also, talking about Nigeria, locally, there's no single consulting firm in Nigeria that can actually handle all of this. I'll give you a very simple example of the way it actually works now. Anytime you've got deep basement to deal with, not even deep basement, just one level basement to deal with. We've not been consulting yet to actually handle it in terms of the deep experience support system. I mean, we've got something that actually is like the actual system to allow for the excavation and construct that basement. That knowledge is not there. And it's not there. Because I've been invited by the Nigerian structural engineers up to 2 times and we're talking about this. And what actually disappoints me is this. Anytime I come around, getting a rabbi structural and I start eating, the young engineers are also receptive, so they're excited. They want it. They want to know more about the reason. They said, oh, that was not Nigeria. How do we deal with that? But which is always so disappointing. I mean, the other ones are the ones we're looking up to actually get things done better in the country. But they're the ones discouraging us from actually accepting, okay, they accepted, but the things that I think we're in serious trouble. And also, that's another example. That was a good example. Is that what we train foundations? And before I left Nigeria, that's my job. Before I left Nigeria for Dublin, PhD. In many cases, we have to do deep excavation for basements. Not just single-level basements in the UK, in most economic solutions, you can't take power or second power, actually, some of those. But because that knowledge is not there, in the consultant branch, they transfer the responsibility onto the panel of craft, in this case, trade foundations. And the trade foundations are like, we put a diaphragm wall. And the diaphragm wall is much more expensive than packaging wall. Massive difference. But because they've got a diaphragm wall in ring, standing in the yard, it's got no job to do, and they have to keep that big going there. They're like, hey, do a diaphragm wall, just to keep the army going. So they don't benefit, but not to benefit of Nigerian developers, but what can the developers do? Nothing. So everyone wants to take the things and then think things really want, but it's not the right way things are going to be, but it is what it is. So put it out and change over time. Next slide, please. Alright. That's the end.
Dr. Franklin was taking us foundation engineering 400 level. We were doing slow stability, passive pressure, active pressure, and Bishop method, rigorous method. All those things look abstract. Now, I'm happy that one of us is an expert in that area, and is, telling us how far he has gone in that area. So I'm sure some of you are being inspired now. All those things that have been taught in class, later on in life, you will really come to appreciate this. Thank you very much. I know Nigeria will get there because I think recently the federal government of Lagos government, they are trying to plan an underground tunnel or something from Badagry or something like that. I think it's somewhere. So whether we like it or not, NI structure will come to the reality, and I'm sure it can be done. Thank you. Now, during the presentation, one of our lecturers in the department working is one of our guys. I think he came in when we were in final year, when we were about to leave the university. So I would say we were not privileged, or he didn't have the opportunity to teach us, but he's one of our guys there. I have to introduce Professor, the only man with a very long initial, Professor B.I.O. Dancy. He is presently the director of physical planning at the University of Ibadan, and is a professor in structures and materials. So, we are very privileged to have him around us. So, in the course of the lectures, some of our colleagues maybe our going class. He came with direct entry to 300 level. So he was in the industry, but he decided to come back. So he was always with us. When you see us, you will know that he's an Egbon, but we all flow together. I want to introduce Engineer Olabode, Also, one man that normally steal my name when we are in class, you see the picture this house. You always steal my name, and you always call my name his name. He's an engineer working with the state government. I want to burst the bubble this morning. He used to be he's a big man. For him to be a big chief of staff, he's a big man. I will introduce Engineer Tosin Akileye. Thank you very much. Now we go into this. Another question on what he has just presented. It's very on geotechnical engineering. I'm sure those of you 400 level, 500 level that have tasted foundation engineering. I'm sure you have one or two questions. We have about 30 minutes for this session because of our time. Thank you. Anybody with question, maybe you can write the question and send it forward. Maybe that will help us. So, 10 minutes, okay, because of our time. So, any question? Any question? Then you must ask question. Oh yes, finally I'm going to set a tough question for you in your exam. Don't ask question. You don't need to fear. I've submitted your question to the engaging design. So yeah, someone's there. Oh yeah, come and ask your question. Come. Just mention your name and your level.
I'm a 4 student. So, concerning the second firewall, I just want to, is it only made up of concrete? Second, you talk about second firewall. So, is it only made up of concrete? Because I'm seeing something like bamboo stuff around. So, I want to know, is it only made up of concrete or what?
In the case of second power walls, as I said, we've got interlocking metal field powers. The field powers are structural. So they've got a steel reinforcement in there, and they're made of very soft maximum compressive strength, 10 Newton per meter squared. But the male piles are the structural piles, so made of proper concrete, 30 Newton per meter squared, or even 40 Newton per meter squared, and the heavier reinforced exterior reinforcement. So what happens is this: you install the female pile first, round the whole perimeter of proposed basement, no steel reinforcements of concrete, and then after that, maybe being in the rig, start coming in between those female piles and start installing the actual structural hard piles, the male piles, and they bite into the adjacent female piles. No, from the top, before you start digging. So you've got to actually draw before you start digging. Because in this system you put it in first would actually be holding the soil and the water as you're digging down. So once you actually install the male piles and you form a good barrier against excavation collapse or groundwater seeping excavation, then you construct a capping beam on them to make them act as a single unit. And if you need to install tie-back anchors, you install tie-back anchors, so you start digging now. If the excavation is going to be deep, not a single level, and then you don't expect this to calculate, you don't expect much of movement, you just start digging down. So digging down, that's the kind of power holds ground, and then silts the groundwater, so you have a nice and dry excavation to whatever level you're going down to. So no bumping, it's soft concrete piles and then hard concrete piles and concrete only. Yeah. Does that answer your question? Alright, thank you.
I don't think they have bamboo in UK. I don't. Another question. Okay, before the question quickly, I just want to introduce someone. When we were here, she was one of those in the office that we normally go to for help. You know, when you need something in your file. I just saw her now. Auntie Umi. God bless you. So your question, okay, the president, come.
Good morning, sir. My name is Alumni. I'm 500 students, and I have an interest in geotechnical engineering as well. So my question is, in the course of your career as a geotechnical engineer, can you tell us how you were able to overcome this challenge?
You see, the special thing about engineering or construction is that every single new project comes up with its own new challenge. So you do challenges every single day. But that's exactly what engineering to do those challenges. You can't do challenges, then you're not what an engineer. That's exactly what an engineer. I think the most interesting one in terms of challenges that I've ever experienced, we did a design for a power retaining wall for a single level basement, but so we designed for that retaining wall, assuming that the maximum excavation of 3.75 meters, 4 meters. But eventually things changed along the line, but we were not made aware of that. They actually went ahead. They actually went down as far, down at 7 meters, almost as double of the basement, without our knowledge, because the behind the wall, so there were cracks developing in the neighboring buildings. And that was when they started. We designed for 3.75 meters, 1.7 meters, what changed. They're like, I know, we thought you were not told us anything. But anyway, so to address that, so we had to start supporting. So anyway, they dug much deeper than we expected. So we had to introduce what we call buttress piles. I never spoke about buttress piles in the presentation course of time, but essentially the permanent network itself will have the physical mechanism between corner styles, factory rented and overall stuff and services. That's what we have to do, and that's stop the movement as it went on. So, but we still have to repair cracks and develop on the neighboring buildings. So that was a major thing. It's quite disappointing, and we saw how it happened, but anyway, we had to rise up the challenge and then it got sorted.
Thank you. There's a question here. It says, what combination of engineering software and programming skills will make a graduate engineer more competitive?
It all depends on what area of structural engineering you want to go into. Do you want to go into structural engineering? You want to go structural engineering, highway transportation, environmental, digital engineering. I don't know too much about those other areas. Although we do structural designs, but we don't do structural designs for both kind of structure. But I can talk about structural engineering. I think the most versatile program or software you will need is a finite element program, because that does everything. It actually captures everything. Plaxis does everything on the ground, from foundation to extension support systems and ground improvement, tunneling, just everything. But they are all got specialists and software packages and meant for different things, for foundations. So I think you can use WALAP, which is WALLAP. You can use CATS, PWS, the CAD and PWS. You can use Oasis Pro. Oasis Pro is software we've got Arab in Nigeria also. But that software package meant for retaining walls only. But FE programs that do everything, and digital engineering, the person gets classes. If what a structural engineers start talking about response as impression, they can let you know the best packages you will need for structural engineering practice. I know for Star, I think you'll go on about Alumni, that specializes in software packages for civil and structural engineering applications. So unfortunately, he's not here today. We've spoken really well about that point. And it all depends on what area you want to go into civil and structural engineering.
For the last year, when we talk about the use of softwares, like you said, one of us in this class, Alumni, is into that. Then it depends on which area are you in structures, are you in water, are you in techniques. There are so many software out there. But before you start using software, I always advise students, you should know the basics of engineering. Software are garbage in, garbage out. Someone who studies physics, who knows his way, can use an engineering software. But you as an engineer, you can use your engineering judgments to know what to do and what not to do. You get it now. It's good to use software. Of course, the world is going to the use of software, but the basics of engineering, you must know it. So that before level, a lady on LinkedIn designed, thank you are a technical engineer, a duplex, a lady, and she provided 42 piles. I was like, wow, 42 piles for a duplex, something that a good raft foundation can hold and stuff like that. So I asked her some question. What was the bearing capacity? I mean, even if the bearing capacity is so low, how will you 42 piles for a duplex? I think it's too much. That was an over design. You know, the lady used Orion, and she was excited about it. You know, I have to try to correct her. Young lady, yes, you know. The exciting thing is, you know, when you use all this software, the financial element will bring out all the drawing, you know, they look so beautiful, those colors. It is not the colors that make it engineering. Please, don't be excited about those colors, you see the white color, the red and everything. No. You have to be able to use your own judgment thing will be much more expensive than using the right foundation. So that's why, please, young engineers, you have to be very careful about the use of this software. You have the skill one that you can consult, who can help you out, tell you what to do and what not to do. One more question before we go into the next session. Okay.
Project Kennedy is actually absolutely spot on. One of the main competences of a chartered engineer is your ability to actually strike a really good balance between safety and economy. If you over designing things, you're not being friendly to the environment, and also you're not being friendly to the end user or the developer. Because as chartered engineers, coordination engineers, we've got to respond to the environment to make sure that with that design, we minimize the amount of natural resources being used on projects, minimize the amount of waste we use on projects, and minimize the carbon footprint on projects. Those are the competencies of a chartered engineer, coordination engineer, and I always have that back of your mind. Because if you look at things, probably a physics student, the secondary school probably be exactly the same. So what makes an engineer? Yeah, so that's very, very important.
One more question. Okay.
Morning, sir. My name is Adil 500 level student. Firstly, I would like to say your presentation was wonderful and it was eye-opening for some of us that love structure. Now, for my question is, what effect does the underground design have on our edge cross when it comes to having multiple of them in close range, and if there is a measure put in place to mitigate the effect?
I think this question is that, take an example, you've got multiple basements around the same area, and how exactly they interact, what influence do they have on each other? And that's a really good question, because we deal with things like that every day. And then taking on as an example, local authorities always, before we actually do design of basements on underground structures, you've got to carry out what they call a basement impact assessment. You plan to build a basement. How does that influence the surrounding structures? How does that influence surrounding underground space? How does that influence the character regime around that area? Will the impact influence the character regime around that area? Of course, problem. So you've got to satisfy the local authorities through proper detailed assessments and finite modeling to capture exactly the surrounding ground, surrounding structures, surrounding water table would actually respond to that excavation being done, that basement being built. So these are things you do at the beginning. And if the potential impacts are not great, we don't get that talk by the local authorities. And that doesn't happen in Nigeria, because as I said, that money is not there. And there's a debt program still in that area, but in advanced world, that's what you get. Basements do interact with each other. You've got to make sure that applications and modeling really. What actually makes you an engineer is your experience in the field. You've done things, you tried that, and then that actually builds your confidence, and that actually builds the capabilities. Even before you start putting calculations together, before you start working on business, you know what exactly the right solution will be. You will know exactly what will work, you will know what wouldn't work, and that's what actually makes you an engineer. And modeling doesn't make you an engineer. And they're just tools to get decision making. So coming back to your question, yes, basements don't interact. Even from deep foundations and tunnels, they interact. But you've got to ensure that you properly realistically model and potentially build that foundation, potentially respond of that tunnel, and make sure that the forward is sensible limits. And then if that's the case, then you can go ahead. But even after that, you won't be required to actually put in instrumentation to actually monitor the actual responses of those structures in service. So when you're doing that, you've got to put it probably in economics within your retaining walls. You may have to install strain gauges on the existing tunnel to see the contraction and extraction in the tunnel lining, just to make sure that you're digging some distance from the tunnel or putting in foundation next tunnel. That tunnel or the lining is not responding excessive, and then you've got to have real-time data from the tunnel in terms of strain, and also you may have to put in crack monitors so there's no cracks developing. So these are the things you've got to put in place. So I think that was a really good question, really. Yeah, and that's exactly you've got to deal with it. So deal with these, like is every now and then.
So thank you very much. Let's give it a round of applause. Thank you very much. Now we go to this session of interaction. We are going to spend about 30-45 minutes because our time is fast spent. So we still have to go to departments, to do our presentation. In the next 30-45 minutes, we are going to have the alumni student interaction, in which we want to share our Thank you. Before we go into that, I think we are going to have about 10 minutes breaks. 10 minutes break. 10 minutes, or we continue. Okay. So we won't go to breaks. I think we start from the start. Let it go right as we speak. So I'm going to call some of us here. Just maybe within 5 minutes, they will tell us their own experience. They are going to share their experience. Question with Immaculate Adeyemo.
Everybody, all protocols will start. Unfortunately, I actually planned for something interactive, but I was told that I cannot share my slide. But I just have decided to just read to everyone. Now, what I just want to share with us, which I've observed over time in the practice, is what I call professional integrity culture. Professional integrity culture. I want to give it to our keynote speaker, who has done well in that presentation and has done so well. In fact, I and my colleague are sat together and saying, we are just looking back, the student will be so excited to ask so many questions. But I believe that when you go back home, you will see the need to nominate and think about what I will share with us today. I was saying that I wish I could go back to 25 years back and say, okay, which direction do I want to go again? But it was so interesting. So, but when you are carrying out your civic duty on your professional duty, there is something that is expected of you, which I want everyone that is being produced by this noble department to carry with them. And that is what I want to call professional integrity culture. You need to have a culture that you are always having that integrity anywhere you go. As an engineer, in fact, the life of many people are in your hand. So many people, by the acts that you put. Look at what Dr. Adegote shared with us. When you are going deep down the foundation and imagine several things that A lot of people will actually trust that, oh, an engineer has done this, an engineer has done this. So what I want to carry with you is a trust. The society has a trust in you. The society believes in you that once an engineer is involved, they are going to rest. They are going to relax. So please, as an engineer, a civil engineer for that matter, do not disappoint people on the trust they are giving to you. So one thing that I want to carry with you on this assignment, because I have a few things I indicated here. Now when you are talking of building structure, you do not build structure as an engineer. Like I said, software is very good. In fact, those software, there was a time I was trying to use Orion. Unfortunately, I did not use it because I was not actually much into that. And a little bit, they put me through at the point I forgot how to manipulate it. But when my guy do structure on Orion, I look at it. When I look at it, I judge. There are some questions I ask them. Why is this like this? Why are you having this depth for a beam? A beam that is spanning this length, you're supposed to have this particular depth. There was a particular building that I was supervising. Now the guy actually, for a story building, was using 600 mm depth for beam. So as an engineer, you can strike between safety and economy, like the engineer said. So you don't just design for the safety. In fact, the client said, everything is good. I went back and said, no, I cannot survive the design. I have to call for a review to be able to reduce the cost. So what I said is that as a people that are just coming out from civil engineering, one thing I want to play with you is this. Number one, learn to document things. When you're on site, learn to document your activity, your involvement in projects. I'm speaking from experience. Your involvement in of your practice very well as an engineer. And make sure you don't give into pressure. There are so many pressure. I was started a project under European Union in Ekiti. And there was a lot of pressure on our side to do some certain undertaking. But I stood my ground and I said, nobody will make this happen. And they knew, but anywhere, anytime I enter that place now, they recognize God in my life. I said, no, we don't want this to happen this way. So what I'm going to say is that you must not give it to pressure. Then you must also speak out. When you notice anything as an engineer, something you discover that is not right, you must always learn to speak out. Your voice counts. Your voice can save so many people. You know, when a doctor operates and they fail, they operate on a man, on the person, and the person dies. But when an engineer fails in structural design or anything, the whole society is affected. So please, let's maintain our professional integrity. And that culture is important. Thank you. God bless you.
Thank you very much. Next man, I will call our one in class, just within 5 minutes, Engineer Alumni.
Good morning, all. It's a great privilege to be here this morning. I just want to share with you part of our past experiences. I'm fortunate to have operated in almost all the areas of what we call civil engineering. You know, civil engineering is a master of all. So I was privileged to operate in geotechnics, artworks, and so many other areas. So I just want to advise you, like the last speaker said, anywhere you are, ensure that that time engineer is not just for the sake of engineer. You must make a difference. You must be counted. Whatever you feel is not safe, please insist. Tell the event this is not safe. We are not going to do it. Even though we design for the worst condition, But at the same time, you need to stand your ground. Most sites that plans to do some undercutting. As an engineer, you need to stand your ground. I've been involved in so many projects, especially when you have all these people that are building and trying to put up a structure. Once you come up with one thing, they say, engineer today. Well, it's either they take it or you walk out of your project. So many times I've done that and I've not lost. So I want to advise you, please don't say, the money, I don't want to lose the money. Please, it's better for you to lose the money and keep your integrity. Okay? Please lose the money, keep your integrity. It's better for you as an engineer. So that tomorrow they will say, this engineer was there while we were doing it. He said it's okay and we have done it. So please, it's a good advice for you. Don't fall for the money. Like the engineer said the other time, how can you put a 600 bill in a house? No, it's never done. It depends on the length of your or your span, rather. So once you see there are some areas you can come in and you can get your construction works cheaper if it's necessary. But there are some areas they will say, okay, engineer.
121 floors. The consultant resigned, the man resigned, and eventually that building came down when you were having more floors to it. And unfortunately, the owner. So please, you are telling me the truth. Now, I want to go a bit outside engineering now. You are gender sensitive. No, the ladies in our class, we really pampered them. We took care of their masculinity now. So I will call our lady in the house. She's coming to tell us about the business aspect of engineering. Esther, please, Esther Nancy. She was Esther Joe.
Good morning, everyone. Nice to see you all, and I'm happy I can see more ladies up here. I think our set was the most celebrated in our time because we have 5 ladies in our set. Prior to that, I think we have either one or none in so many sets. So, up 2,000 sets for the lady. We started what I have been able to do as a civil engineer. As a lady, immediately I finished school, the marriage always delayed us a bit, especially some of us that really want to concentrate on raising our kids well. So I was actually into business, like my colleague has said, while I was in school. As a student, I used to run a boutique. When I graduated, after a few years, I delved into solar business. And because of my engineering background, I was able to self-train myself in solar. And we did a lot of jobs. We were able to work for so many banks, MLC, Insurance, this old bank, anyway, some of the old banks and some other outlets, Power Discount House. Even with then, Jonathan, the vice president of Nigeria, will lead his first bank system in his house in Nigeria. So I was able to self-train myself and we did very wonderfully well. After a few years, I also went into a little bit of my civil engineering, and I want to encourage us. You don't have to totally just abandon your profession. I went into the roofing part of it, that is building material. And this is how I've been able to do very well. Even though I am into business, people say when you are looking for quality so coated, the only company that is left for quality is low. Sorry, but what gave me this edge above others is because I am a civil engineer, because of my profession. I'm very particular about every product that I do. Presently, the quality. It's not just like traders. I think that is where, even though I'm into business, That's where I stand out with my profession. Because I understand the importance of the quality of every item, be it even up to the doors. You know, every building material that I need. So I want to encourage us the ladies. You don't have to totally drop it off. Ladies, even the men, you don't have to totally throw it off. When you leave, you know, life will determine where you are going to go next. So you can look into it and see what you can still achieve with your civil engineering. Thank you all.
I'm going to call the fine boy in our class. It has been bank, industry, here and there. So the fine boy in our class, should I call him together? Fellow. Yeah, it's NLSC, by the way. It's a fellow of the United States of Engineers. I think we I want to call the female.
Thank you very much.
Like, he's still fine, Abby.
I've had two proud moments in life, you know, as a graduate of the Department of Civil Engineering. One of them was the day we took the group picture that you probably saw, you know, in the slide pack, and then today. Because honestly, if, you know, in our own time, we had this sort of opportunity to meet, you know, graduates, people from the department that were in industry, that were in academia. It would have inspired us. So please, I appeal to you students, soak in, you know, all the information and all the knowledge that you can, you know, in this short time that we're with you. Just to ask, how many of you were born in 2000? How many of you students? I can see a few hands. How many people were born in year 2000? Okay, there are some of you. Because the world has changed. When we graduated, computers were just, you know, starting to come up. Software was there, but we were not, you know, able to take advantage of those things. But of course, as we went into our careers, we were able to develop ourselves. So as Professor Akele introduced, my own journey has not been, you know, strictly civil engineering, but civil engineering has brought me to where I am. One important thing that Dr. Adepute said was that how you finish in UI can determine the amount of work you will have to do, you know, to get into a profession or to get into your discipline. Struggle to get that high achieving degree, whether it's 2-1, whether it's first class, or even if you get a 2-2, it just means you will have to work harder than those who get 2-1. So I started off on graduating, let me say this. I knew that I would pivot away slightly a bit from civil engineering, and that was because I was inspired to go into oil and gas engineering. Partly because of the money, you know, because I saw that they were doing better than what I saw in terms of civil engineering, and my internship experience was a bit rough. You know, as a civil engineering intern, then it was a rough experience. So I saw oil and gas, and I ran in that direction. But what I would say is, during NYS, I was able to get into, you know, an oil and gas company, and because of my civil engineering degree, I was put in the projects, you know, department. But the interesting about projects in oil and gas is it's not civil, it's not structural only. There's so many elements. There's piping, because we use oil and gas. There's piping, there's electrical. So you have to, you know, be familiar with those things as well. You most times act as a project manager, but you have to be knowledgeable in all those areas. So what I would encourage you all to do is, you know, take your studies as seriously as you can, but remain curious. You have the opportunity that you did not have, and that the world is open to you. Whether it's through your phones or through your laptops, you can see what is happening. You know, just as Dr. Victor was painting the picture for us about what he's doing in the UK, he did in Ireland, the world is open to you. You can see what's going on.
So you can decide you want to stay civil engineering or you want to go into something else. My journey, as I said, was not direct. So I did my NYSC in another gas company, and then the first actual job I got, with an offer letter was in the bank, and that was also intentional because banks were paying well. And I will tell you something that was interesting. The day I interviewed for that job, I sat before a panel of backers. And when they saw civil engineering on my CV, it was like they were looking at a superstar. So that's why I said, take your civil engineering degree as, solid, very solid one, especially one from the University of Ibadan. So, they didn't even ask me too many questions. They were just asking me, how's your family, I got the job. And then the first day on the job also, the first day on the job, they put me in a new department called, it was a shopping bank. They put me in a new department called consumer banking. And immediately, if you know what banking in Nigeria is like, it's all about marketing, find customers, find money, find deposits. So they already, grouped me with some people that go marketing, go and look for millions, go and look for, Then the head of the department saw me and said, are you not an engineer? He just took me out from that group and put me in the unit that was in charge of e-business at that time. What do you call it? Debit cards, almost US cards that come out at that time. It was a value card. So the bank was pushing that product out at that time. But the man saw that these guys are engineers now. What are you doing? People who are going to change money. Come and help me develop this, this unit. And it was a very good experience. Because at that time, people opened my eyes to what value card was. You could put, at that time, you could load the actual money digitally on the card and then spend, the money. So we're deploying it in the bank branches. You were learning to use the servers. It was technical. That's what I would say. So your CMA can take you in many directions. If you decide you want to go into banking, you want to go into, I had, people that I saw who went into programming, computer programming, they were developing software. Many of us here in academia, you can't do anything. So just know that your degree, your degree from UI already puts you steps ahead of a lot of people. First of all, you are an engineer and then you are from UI. I had offers for admission for masters just because I finished from UI, even before I finished. Overseas, what I didn't have was money to go and pursue those degrees at that time. So your degree is important and the world is open. But summarizing what everybody else has said, it's important that you remain curious, you ensure that you know exactly what your engineering study is about. You are adaptable, you associate with the right people so that in whatever direction they're going, they can carry you along. And my prayer is, when we come back for our 50th anniversary, you guys will be having your maybe 25th or 20th, and I'll be able to see your faces looking like the transition that you saw. Many of us were looking hungry, but thank God for where we are now.
Thank you very much. Okay, that's next time. Some of us will be eating almost 80 by that time. Thank you very much. Now, there is one of us who's supposed to be here. I call him Oga Banker. Since we left school, he joined Zenith Bank. He has risen to the top of Zenith Bank in days. It was last week that he just told me that he has to travel out, the bank has to send him somewhere. It was so painful to him. He would have been here. That's showing my guy. You see, in the picture, you see him wear tie. At 100 level. Today he's still wearing tie. So it shows my guy is supposed to be here. He's supposed to have told us some things about banking and stuff like that. Notwithstanding, we have another person, as a civil engineer, you can operate anywhere. I talked about someone who was chief of staff to a politician and who is called into the civil service to work with the state government. So I will call him up to come and tell us his experience. Tosin Akiyele. Oh, sorry, Tosin Akiyele.
tell you my president. Currently the Director of Transport Policy and Coordination of the State Ministry of Transportation. I believe I'm addressing both students and lecturers and faculty and Goa. I really want to emphasize something before I go further. The relationship between the ground and the town, I believe you all understand what that is, matters so much. I also want to emphasize the importance of versatility. When I was in UI, I leaned towards water and the environmental engineering. I never thought I would find myself in transportation engineering, ever. And at that time, my project in school was the sign of the residual engineers of dam. So when I got into the civil service, I found myself in the Ministry of Transportation. And I realized that the entire transport sector, the entire gamut of activities in the transport sector is engineering and civil engineering primarily. This now gave me an exposure into aviation, marine, land transportation, rail, and all of that. And that's one important thing about civil engineering. I know you may not know, but you are fortunate to be in civil engineering. So, being there now, I found myself having to direct the production of the first ever strategic transportation master plan for the state. And that was about the synergy, cooperation, the engagement with academic institutions within the state, because then we were looking at for us to have a good study that we underpin our conclusions on some of the initiatives to be part, I think that were part of the master plan. We needed the academia to be part of that engagement. So we looked around and found another person about the university, being a state-owned university. And we immediately crisscrossed the entire state, taking data and then processing them to produce the first ever, which I directed. And after that, the implementation. The implementation has to do with, okay, what can we do in the short term, the medium and the long term? You are aware of standard delivery from Lagos to Ibadan by 686 by the federal government. And now the extension of operations on both that particular line, which Lagos State is running as the red line, we have to do the same in the state. The extension of the red line of the digital of the state. That was also under my supervision. The extension of the blue line from Omaiko also is electric vehicle unit power also very good. So my journey through this development, the airport that we have in Ogun State today, the Gateway International Airport, is the first of its kind. It's the only one with a license passing now. And that's what fell under my department. Why am I telling you all of this? It's not for you to know what I've done, but to understand that once you step out of this space, the opportunities are endless for civil engineers. The reason why I'm the one in charge of all of this project is that of all the directors in the ministry, I'm the only one with civil engineering background. Others have mechanical engineering. So they always attempt to, well, I don't want to say things that will make it like within that side. So, but I'll tell you that we are developing a deep support also now along the back of the way, just after the Lekki and Dangote deep support in Lagos, about 16 kilometers along that line, not too much along that line. We will say it's developing with customary this Netherlands-based company. I'm not doing as well. This, if we have up to 2 or 3 civil engineers in that ministry now, they are going to be doing a lot of all of these things. students, when you are here, don't just think that all those talks in those talks. I remember Professor Franklin. Those are what I thought engineering was all about: structure, foundation, all of that. But what I'm doing now, I never had an idea as a part of engineering, civil engineering, whatever that. So, please, that mindset to make you see civil engineering.
Who owned a consulting firm, he is on his own and he's doing fine. So I want to give him also time to speak. Engineer Bella.
Thank you very much, Prof. In the moments of the talk that have been going on so far. Interestingly, before I started operating my own firm, I had worked in almost every sector of civil engineering at times. Then I also worked briefly as a shell contractor before I now floated my own company about 10 years ago. Now, I will not go to what all they have said, but I want to talk about street credibility. How you can be a successful civil engineering consultant or contractor, and if you want to be a business owner, an entrepreneur. Now, the first thing you need to be able to do, you must be able to profile your clients. You must be able to profile your clients. There are some clients that if a job is going to cost 20 million, are you getting me? If you give them 10 million, be okay. They will not give you the job. Are you getting me? And there are some other clients that you know that this person cannot afford more than 10 million, and at that 10 million, is going to make profits. So you just have to do that job because all clients are not the same. The number two, you need to have finicky eyes. Your eyes have to be very finicky. What I mean by finicky is that if you want to be a business owner, you want to be a consultant or a contractor, you can stay here and you know when a word is in alignment or not. These are things, trainings that the school is not going to teach you that, but you get this street credibility on site. You can stay here and you know that this word is not straight. You need to do that. Then you need to know a lot of cost engineering. You know you are not a QS, but you know cost engineering. If you see a wall, you should be able to know, okay, this wall is going to be 100 blocks that will finish it. Once you tell me the dimension, I'll tell you the amount of blocks. If you give me a concrete volume and the concrete mix ratio, on the spot, I will tell you the number of bags that's going to be involved, the amount of tonnage of granite, and the aggregates. So these are things you need to know. Then I want you to be also very careful. You know, a lot of my colleagues have talked about integrity. I remember when I was I was working on a federal project, and what we have done, the amount of kilometers we have done is not more than like 2 kilometers. But when they raised the certificates from the company I was working with, they have raised the certificate about 5 kilometers, and they brought it for me to sign. And I know that we have not done up to that on site because there was a connivance with the federal officials. I said, I'm not going to sign this certificate. So somehow I was able to dodge it and push it to the QS of the company. So it was the QS that signed it. Because I want to be able to go to my house and sleep with my 2 eyes closed. And so there's a lot of money in school, and you don't need to cut corners. If you know your audience and you're able to think outside the box, the sky is never your limit. You may even end up employing other engineering disciplines to work on them if you strive for the best. Thank you.
This Ibadan bank fraud, project and everything is I'll call him out before that, I just want to repeat what he said. Integrity matters. Please, clear to think you are very stubborn. When you need to be stubborn, you have to be stubborn because of your name. There is no cost on that. You are trained engineers. UI says when they are on your day of graduation, when the registrar will call you out, they say these have been found worthy in character and learning. It's not a joke, it is real. So please, that character really matters. Like you said, there is money in civil engineering. Even people mentioning your names. I practice as an academic. I'm still in the industry because from the industry I went to academics. There are people still coming to come and do jobs. Recently, last year, I don't know the person that gave them my name. And I'm a structural engineer. There is this on those state water projects that they just put my name. And within the project, I was paid handsomely. I won't tell you how much. You understand? Because people know your work. Till today, I don't know the person that gave them my name. That this guy can handle the job. I did a very good job. No, we do more of the consultancy aspects. And so please, the field is very wide. Lastly, before that, I want to call Engineer Jack Nunko to tell us how to supervise projects that involves a multi-body.
Good afternoon, Paul. Yes, my colleagues have said so many things, so I don't really want to take time. Just as the MC said, I'm the basically, you are either because you want to be in academics. For you to perform excellently well in your field, you need to have some additional knowledge beyond the first degree. And take for instance, the course maybe when you were in school, you did the water resources engineering and all those courses. But there are some courses that they won't teach you at the level of first degree, but you meet them in practice. So I want to encourage us. I don't want to go into different kind of those things, but it's very, very important. I mean, engineering is very wide. Talking about civil engineering now, maybe up to 10 or more than 10 fields. It's always you go for your masters. At worst, even if you don't want to be in academics, you want to practice fully. You know, most of us eventually are self-practicing. How many people will academics say? But try and strive for excellence. And they have said it, you cannot, I don't know, because if you have said strive for first class, it depends on the level you are. Somebody is foreign level, it's already living in 2-2. Don't say that, I cannot take for. Even if you graduate in 2-2, you can still become the best in your field. But if you are in another level, please strive for the best. So whatever you find yourself, you know, don't look down on yourself as a civil engineer. There will be challenges. People who want to look at down your box. Take your time. Now, you mentioned that this is what control. There are a lot of challenges to face. You know, some of my colleagues have mentioned it. Who will come with you some kind of trying to compromise? They will come with offer. Stand your ground. It's not about money. Money will come. Money will follow. But maintain your personality. You know, definitely the entire situation has come that everybody's about money. Nobody's going to have integrity, but your integrity is very, very important. So when you start your excellence and integrity, other things will follow. So my students, I just want to encourage you, try and be yourself, be the best wherever you find yourself, and don't allow anybody to want to push you. So like I said, you want to compromise everywhere you want to function. Be yourself and try to have that honor to work out if the government does not represent your personality. Thank you.
Thank you very much. So I don't know if you have a question. Yeah. Please, it's an interactive session. Please feel free to ask questions. Even after the program, you can meet any one of us to ask questions. Are you getting me? You can meet any one of us. And it's me, I'm still available. I'm still within you guys, Abby, till next year when I will be.
Good afternoon, everyone. I'm super excited to be here. And my name is Ibadan, a final level student of this department. So my question goes to the mother of the house. them do after school. And I know you've been in that show, and I just want you to like explain how you were able to overcome that phase. That's my first question. So my second question is, about 2 months ago, I've always been interested in business. I used to run a business like a few years ago, but had to study because school was quite demanding. So recently, I got an advice from, I went to meet someone I know, he's a businessman. I told him I wanted to do business part-time, business in structural materials. I'm interested in selling structural materials as a part-time stuff. So even if I'm doing a 9 to 5, I can have that at the side of it before I finally delve into business later on. And then when I went to meet him, he said he had like similar business idea, and then instead of helping me instead of giving me tips on how to start, he gave me an offer. He gave me a partnership offer in his business. Though he has not started the business, he said, oh, he's going to wait for me till I'm done with school. And then he told me that if I'm willing to, I can partner with him, and then I'll get entitled to 30% of the business revenue. But he gave me a restrictive condition which I have to follow. He told me that, oh, I won't be allowed to work anywhere else. So if I'm partnering with him, it's going to be like a full-time business. So initially I was super excited about the partnership because it's something I've never really done before. That restrictive condition kind of made me do that. And I think the reason was later when I realized that he wanted like a female, should I say, a female identity in his team. And to me, so just like, oh, maybe it's fun to take everyone to the fact that, oh, I'm a lady who is active and feels great, like attract more clients in his business. So for business, is it necessary I have to maybe work on that someone, or can I just start with my own?
A lot of factors actually kept my own business life. As at the time I was leaving university, I was already 26, 27. So getting married as at that time, I was already 18. And the business aspect of my life actually started even as at the time I entered the university. And I didn't start big. I started small. I had an opportunity to have attended Lagos State University. Pretty good program before I jumped to the university. Where we used to buy her shoes. That's where I started from. I tell a lot of people, I tell them, I started this business a long time. I paid my dues. It was a thing that I started from. When we are talking about business, that is a very small way to have started. I was selling shoes among my mates. I was going to my friends' schools, trying to sell to them. And before I graduated in UI, because I was able to gather money together, for me to be able to provide schooling, and so I graduated from someone overnight. It could even start as small as I'm selling suits. That would just be the beginning. You must have an experience in that way. So the glory of God, I have a lot of men, people that come to me, young people. Work for, and remember I said I was already a full woman. I have a husband. So it makes it a lot easier for me to be able to go into doing something big, like going into solar. Yes, it was very tough to be able to start. I remember I even had to pick up my thermodynamics. I had to go online to train myself. I went for a solar event somewhere in Abuja, and these people came from America, and I remember them saying something. They said, look, I think you are going to need the microphone to establish because I can really this practically. I like practicality. I say system engineering is a very easy profession, you can relate it practically by So, in your own case of doing business, I would advise you, business is not something that you just rush into. As much as you love to do business, you have to start somewhere. Business is as if you have to work. At times you fail, till tomorrow you still fail. The only thing is that you don't give up, you keep moving. So we're talking about partnership. Before you go into partnership, I will tell you how to test your hand and what you can do. Start small. Thank you.
This person that is trying to give you 30% whatever, I hope he's not trying to employ you. I don't think that is partnership. He's trying to employ you technically from behind. So you have to be very wise in your decision. I'm sure you can only see, let me call her Muniesta. After the program, she can put you through. Yes, any other question? Participants? Okay. Okay, let me call the coalition leader here before I call the president. They are gone.
Alright, good afternoon. My name is Bruno Bassi. I'm a 300 student of the department. So my question is for Engineer Ojo. So I am very much interested. Yes. Okay. So I'm very much interested in engineering policy and whatnot. And as someone who works in the nation, what steps do you think I should take in order to tilt my career towards that situation? Because last year I served at the Nigeria National Assembly as the Senator for Sokoto South on the Committee of Public Works and Infrastructure. And I discovered that Nigeria's framework does not have anything for constituency development. So I'm actually trying to look into a way that we can expand this, our constitution, and accommodate things like this into the country. Thank you very much.
Thank you very much. Let me start by saying policy in itself is a means to an end. It's not an end in itself. So your interest in policy is good, but I rarely see anybody advise others to go into civil service to government. And it's the government that will do policy. It's the government that sets the policy. Policy encapsulates the